to New York's Indian Point Energy Center in 1971. The arsonist was a plant maintenance worker. Proliferation nuclear. Proliferation is the spread of nuclear weapons, fissionable material, and weapons-related nuclear technology to states that do not already possess nuclear weapons. Many technologies and materials associated with the creation of a nuclear power program have a dual-use capability, in that they can also be used to make nuclear weapons. For this reason, nuclear power presents proliferation risks. Nuclear power program can become a route leading to a nuclear weapon. An example of this is the concern over Iran's nuclear program. The repurposing of civilian nuclear industries for military purposes would be a breach of the Non-Proliferation Treaty, to which 190 countries adhere. As of April 2012, there are 31 countries that have civil nuclear power plants, of which 9 have nuclear weapons. The vast majority of these nuclear weapons states have produced weapons before commercial nuclear power stations. A fundamental goal for global security is to minimize the nuclear proliferation risks associated with the expansion of nuclear power. The Global Nuclear Energy Partnership was an international effort to create a distribution network in which developing countries in need of energy would receive nuclear fuel at a discounted rate, in exchange for that nation agreeing to forego their own indigenous development of a uranium enrichment program. The France-based EuroDiff, European Gaseous Diffusion Uranium Enrichment Consortium, is a program that successfully implemented this concept, with Spain and other countries without enrichment facilities buying a share of the fuel produced at the French-controlled enrichment facility, but without a transfer of technology. Iran was an early participant from 1974 and remains a shareholder of EuroDiff via Sofidif. A 2009 United Nations report said that the revival of interest in nuclear power could result in the worldwide dissemination of uranium enrichment and spent fuel reprocessing technologies, which present obvious risks of proliferation, as these technologies can produce fissile materials that are directly usable in nuclear weapons. On the other hand, power reactors can also reduce nuclear weapon arsenals when military-grade nuclear materials are reprocessed to be used as fuel in nuclear power plants. The Megatons to Megawatts program is considered the single most successful non-proliferation program to date. Up to 2005, the program had processed $8 billion of high-enriched, weapons-grade uranium into low-enriched uranium suitable as nuclear fuel for commercial fission reactors by diluting it with natural uranium. This corresponds to the elimination of 10,000 nuclear weapons. For approximately 2 decades, this material generated nearly 10% of all the electricity consumed in the United States, or about half of all U.S. nuclear electricity, with a total of around 7,000 terawatt-hours of electricity produced. In total, it is estimated to have cost $17 billion, a bargain for U.S. ratepayers, with Russia profiting $12 billion from the deal. Much-needed profit for the Russian nuclear oversight industry, which after the collapse of the Soviet economy had difficulties paying for the maintenance and security of the Russian Federation's highly enriched uranium and warhead. The Megatons to Megawatts program was hailed as a major success by anti-nuclear weapon advocates, as it has largely been the driving force behind the sharp reduction in the number of nuclear weapons worldwide since the Cold War ended. However, without an increase in nuclear reactors and greater demand for fissile fuel, the cost of dismantling and downblending has dissuaded Russia from continuing their disarmament. As of 2013, Russia appears to